everyone. Welcome to another NLP Inside the live show, and thank you so much for joining us today. We will be here live every other week for 15 minutes to talk about everything NLP with industry leaders. I'm David Talby, the CTO of John Snow Labs, and today I'm very excited to welcome Stella Biderman, lead scientist and mathematician at Booz Allen Hamilton. She's done extensive research and published multiple papers on large language models, and will share her insights with us in today's conversation. Welcome, Stella.
Thank you. I'm excited to be here.
Thank you for joining us. Can you please just, let's jump right in. Can you please share your background? How and why did you get into work on large language models?
Sure. So as you said, I work at Booz Allen Hamilton, which is a tech-oriented government consulting firm, or a government consulting firm that has a lot of technical clients. And I started off doing machine learning work, kind of supporting and empowering government data scientists. So I'd work with people who have like social science or government backgrounds and who are actually leveraging machine learning and data science to do their jobs, but who may not have like the math and stats backgrounds to develop new types of algorithms and stuff like that. And so I was, the researcher who built the tools they'd be using in a couple of years. And, transformers are a growing part of the machine learning landscape. And that's kind of how I originally stumbled into them. And as I became more aware and also more involved with transformers, it just very quickly became clear to me that it was something that I wanted to kind of focus in and invest heavily on.
Interesting. So you're working as part of Luther AI, and would be interesting to tell us a bit what that is. And then you're helping to develop free and open source language models like GPT Neo and GPT Neo X 20G. Can you please tell us more about Luther AI and what the community can expect from the new models?
Sure. So Luther AI is kind of a grassroots research institute that coordinates and exists largely over the internet. We have members in the United States, in Europe, in Africa, in India, in China, Taiwan, Australia, really all over the world. And what we got started around was the idea that we wanted to play with and do research using GPT-3, OpenAI's model. And at the time that we started talking about this, OpenAI wasn't letting people do that. And so we said, okay, well, if we want to do research using this, because we think it's a really cool technology and we think it's going to be an important part of the future, how hard can it really be to train on? So we kind of, that was how we got started. We started working on developing resources like open source data sets, open source evaluation benchmarks, and then eventually started training models. As you mentioned, our 2.7 billion parameter and 20 billion parameter language models that we were training. And at the time, nobody was really releasing these to the public. There was a group at Google led by a man named Colin Raffel that trained a couple encoder-decoder models, which are a different type of model than GPT-3, and released those to the public. But other than that, no one was really training and open sourcing language models. And we saw that was a real detriment to the research community because a lot of people were interested in doing research with these models, but didn't actually have access to them. So that was kind of a niche that we stepped up into.
And can you tell us about those models are there now? They're released. They're available.
Yes, GPT Neo X 20B is available on our website. It's available on the Hugging Face repository, which is a very popular way to interact with transformers. You can query it yourself at 20b.luther.ai, which is a public endpoint funded by a company called CoreWeave that just went live today. Yeah, so they're out there. People are doing research with them. There are a dozen academic research groups that I've been talking to who either have already done research or are actively pursuing research using these models.
Oh, that's fantastic. I think definitely it's critical to have really those kinds of models freely available, right, open for academia, for industry. Definitely, I think it's an important thing for the entire community. You also have recently published a paper on a VQGAN Clip, which is also a free and open source model for open domain image generation and image editing from natural language prompts. Can you tell us more about it and how it differs from projects like the similar projects from from Google, from OpenAI, from Microsoft?
Sure. So the paper came out recently, but VQGAN Clip has been around for close to a year and a half at this point. It was something I'd mentioned that Eleutheria is a very grassroots organization. It was something that people started hacking together using Google Colab notebooks, hanging out in our Discord server, and just kind of posting what they were able to get. And people were slowly working on iterating on and kind of improving these techniques. So what it is at its core is recently, there has been a very large amount of interest in text to image generative models, models where you can input a text description and you get an image back, or editing models where you insert a image and a piece of text and it edits the image to more closely match the text. So for example, you might put in an image of someone on a horse and the text, a man riding a donkey, and the model would take those two as inputs and figure out that it needs to replace the horse with a donkey and produce a new image that looks mostly the same but has a donkey instead of a horse. And these models are extremely expensive. Language models get a bad rap for being expensive to train, but these models are obscenely expensive. It is far, far, far more costly to train on a per parameter basis, on a per performance size basis, to train a text to image model than it is to train a pure text model. So kind of the thing that we started wondering about was whether we could hack together a text to image model using an image model and a text model that were previously separate. And so that was what we were able to do. VQGAN is a model that produces images, and Clip is a model that is able to measure how similar a text and an image are. And so what we were able to do is, without any additional pre-training, use the Clip model to kind of critique images, and then we regenerate them in a way that's going to satisfy the Clip model a little better. And kind of through this iterative process, you can actually do natural language-based image generation and editing. And this is really cool. It's slower than models like DALL-E, like Glide, but it is way cheaper both for us as researchers to produce as well as for people to use. Like, even if DALL-E was publicly available, most people don't have the ability to run DALL-E on their home computer, whereas VQGAN Clip, like I said, we did the development work in a Google Colab notebook. Anyone can, and tons of people do use this on a regular basis in Google Colab. It'll take 2-ish minutes to generate an image, but that's a lot better than not having access to the technology at all. Yeah. And so kind of I would say that's kind of the key difference between this and other models like Google's image gen or OpenAI's Glide and DALL-E, is that our model is designed to work in low resource settings. You do not need a fancy GPU. You can use very cheap GPUs. We actually have a bunch of comparisons about this in our paper. You can use very cheap GPUs. You can use very little total computing costs, and that kind of really increases people's ability to play with and hack and use on their own these models.
Yeah, makes sense. You've also done a lot of work to evaluate the quality of data used to train large language models, which is of course of interest for general society reasons, responsible AI reasons. So can you share a bit about what you have learned and how does it impact the current gen language models?
Yeah, that's a really big topic. Training language models, producing data sets to train language models on is extremely difficult. The kind of my first NLP paper was about the Pile, a data set I put together along with a bunch of other people, a data set I contributed to, that we designed to train language models on. And we used that to train like a 2.7 billion and a 6 billion and recently a 20 billion parameter model. And just as a reminder, like the very, very cutting edge models that are kept secret inside Google and stuff have hundreds, 540 is the current record, 540 billion parameters. So we're like an order of magnitude smaller than that. But the amount of text that our model requires is honestly mind-boggling. It is measured in the billions of pages of single-space text. Now, it turns out that there's just that much text in the world. There is a mind-boggling amount of text in the world. But because, billions of pages is so much text, it's not really possible to, in a meaningful sense, read through and validate what is in your data set. It's just like going to take too long. You could pay every person in the world to read a page an hour, and it would take more than a year to go through 1 billion pages. So what we so I've been working a lot on auditing, on improving automated crawling data sets, and in general trying to figure out how to put together these tens of billions of pages of text and in a way that is actually going to be accountable, auditable. In some sense, you would know what's in it even if you don't have the ability to read through it all. So yeah, I've worked on developing data sets for Eleuther AI. I've been working as part of a larger collaboration called Big Science to develop a data set that we're currently training a 100 billion parameter model on. I've been involved with efforts in auditing where we actually paid people to go read through purportedly multilingual data sets that were just kind of scraped from the internet and actually document like how multilingual they are, what languages were actually there, what languages were not there, because a lot of the automated scraping tools don't work very well. And so, lay out what the landscape looks like. And overall, I'd say what I've learned is that it's hard, expensive, and difficult, but extremely important and extremely valued.
Yeah, but in a sense, trying to collect really all of the digital text that's available, right?
Yeah,
in the world. That's it's. I don't know if we've ever tried that, right?
It's extraordinarily difficult to do in anything remotely resembling a transparent or even like knowledgeable way, but we're working on it.
Yeah, so it's the new age librarian, basically, right? That's the job.
Yeah, there's actually been some really interesting research by, I'm blanking on who the authors are, but like specifically about data archiving and librarianship and how NLP people can learn from them about data curation and data processing. Really, Lessons from the Archive is the name of the paper. I'm blanking on who the authors are, but it's a really interesting paper.
Okay, I'll look it up. So what new capabilities that new language models will gain within the next, say, 1-2 years are you most excited about? You're thinking a bit forward.
So the thing that I think NLP really has the most to gain from is what I would call grounded language generation. So right now, the best way to think about the cutting edge language models, whether it's GTP Neo X, whether it's GTP3, whether it's Palm is the one from Google that came out recently, is that they babble. They produce text that kind of mimics or apes or parrots human speech. But they are quite literally trained to produce the most likely next word. Nothing in their training process rewards them for generating things that are true, that are useful, that are well-reasoned, or anything like that. And to an extent, you can improve upon this by getting better data curation. If everything in your data set is true, then by mimicking what's in the data, you're more likely to produce true statements. But I really think that the next level in NLP is going to be coming out of developing techniques that actually allow you to train a model not just to create human-like speech, but actually like true speech or speech that's grounded in some kind of physical reality and less disconnected from the real world.
Interesting. And what goals are you optimizing for? Is it being able to convince, being able to be truthful, being able to be interesting? What would you measure?
It depends a lot on what your particular production goals are. I think that perhaps the most important thing is factuality. Right now, language models struggle with a lot of basic common sense concepts like which is bigger, a bread box or an elephant. That particular example shows up in a lot of internet text, and so it's easy for it to learn that. But it suddenly, if you change the word, sorry,
depends on the size of the box.
Yeah, but if you change the word bread box to like mushroom, it's very plausible the model might not know if a mushroom is larger than an elephant or not. And so specifically like developing knowledge representations and the ability to instill in the model a actual understanding of facts about the world and kind of use that to guide its generation and use that to inform its generation is, I think, really the key. So I guess I would say factuality, but almost in a sense, in a way that humans take for granted. We talk about we want the news reporting to be true. We mean we want it to be truthful. We want it to give an accurate representation of the world. We don't mean that like we want it to have a basic understanding to the point where like we can trust it to know whether a mushroom or an elephant is larger. So I'm not even talking quite that far in terms of like, having correct or, correct factual knowledge or correct like scientific knowledge or particular political opinions. I mean, like really basic knowledge about what is and is not in the world.
Mm-hmm. And you think we are 1 to 2 years away from seeing initial results in that space?
I think so, yeah. It's really hard, largely because the current techniques for generating text work very, very well at generating text. And it's hard to come up with something that is going to give a more big picture useful reward signal, or a reward signal that's more aligned with the kinds of things that we care about, but also work as well at getting the model to generate coherent text in the first place. So yeah, there's a lot of really interesting work that's been going on about this, and I do think it's something we're going to make real progress on in the next couple of years.
Very interesting. Well, Stella, thank you very much for sharing your knowledge with us and joining us today. It was great talking to you. I definitely learned a few things. Thank you.
My pleasure. It's great to be here.